first type of numerical which is asked from here, which is also very famous numerical, where r vector will be given, f vector will be given. We have to calculate torque vector with the help of r vector cross f vector. No problem, no problem. Now second type of numerical we are going to study, where we will learn how to calculate torque with the help of r perpendicular into f. Second situation, first type of situation, cross product. Second type of situation, how to find value of torque. And with the help of value, how to calculate remaining things which are asked in this part. So we are going to talk about that part. Okay, no problem, no problem. Yeah. So type 2 numerical. Last class, whatever we studied, that was type 1 numerical. Now we are going to talk about type 2 numerical. Second type of numerical which is asked from torque. No problem. Yeah. And here we don't require to do any cross product. Directly values will be given. We will calculate directly. Yeah. So always remember, in second type of numerical, we have to calculate torque. We can calculate torque directly with the help of r perpendicular into f. And I told you this r perpendicular is the perpendicular distance of force from axis. No problem. Yeah. So torque will be equal to r perpendicular into f. But here only torque will not be asked. It's not like that r perpendicular given, f is given, so directly you will multiply r perpendicular into f, you will get the value of torque. No. Here they will ask you something else. First we will calculate torque. First step again, we will calculate torque without any cross product. R perpendicular into f will give you torque. And from here they will ask you alpha. Actually from here they will ask you find angular acceleration of the body. Yeah. So first we will calculate torque with the help of r perpendicular into f. And the way you remember in translational motion, we used to write f equal to ma. In the similar manner, in rotational motion, we write torque equal to I alpha. You can see rotational analog of force is torque. The same rotational equation. Same, this was translational motion, this is rotational motion. So rotational analog of force will be torque, rotational analog of mass will be moment of inertia, rotational analog of acceleration will be our alpha. So the way we write f equal to ma in translational motion, same thing in rotational we write torque equal to I alpha. So first we will calculate torque with the help of r perpendicular into f. Then we will equate that torque to I alpha. And from here we will get the value. That's why we studied moment of inertia. Actually you studied different moment of inertia for different body now. So where we will use those moment of inertia. So actually we use that moment of inertia to calculate alpha. First we calculate torque with the help of r perpendicular into f. Then we equate that torque to I alpha. From there we will get alpha. And always remember, once you get alpha, you can find omega also. You can find angular velocity also. You can find angular displacement also with the help of equation of motion. The way we have equation of motion in translational motion, same equation of motion you have studied in circular motion, same equation of motion we use for rigid bodies also. So first with the help of r perpendicular into f, we will calculate torque. Then we will equate that torque to I alpha. Alpha will come. Once alpha will come, we can calculate omega. Omega equal to omega naught plus alpha t. We can find angular displacement theta also. Omega naught t plus half alpha t square. We can use third equation also. Omega square minus omega naught square equal to 2 alpha into theta. And there we studied Galileo's ratio. At RPM and RPS. So that situation you will calculate omega with the help of, you have done in circular motion, 2 pi f. If frequency is given, then we will calculate omega with the help of 2 pi f. Sometimes they will give you number of revolution. So always remember, number of revolution will be equal to theta by 2 pi. or you can say the total angular displacement theta will be n into 2 pi. So these are the different things which we'll use in this part. So first you can write this. Yeah, is it okay? Everyone got idea? So first target will be to calculate torque. Torque we will calculate with the help of r perpendicular into f. Once torque will come, we will equate it to I alpha. Alpha will come. Once angular acceleration alpha comes, we can find everything. They may ask you find angular velocity, they may ask you find angular displacement. We can use this equation which we used in circular motion also. They are also studied about angular velocity, angular displacement, angular acceleration. So those equations we can use for rigid body also. So first torque will be calculated with the help of r perpendicular into f. Second we will equate that torque to I alpha. Alpha will come. So generally they ask alpha only, but after alpha if they ask you omega, you can find omega, you can calculate theta, you can calculate everything, you can calculate Galileo's ratio, you can find omega with the help of frequency, you can find number of revolution theta by 2 pi. Is it okay? Done. Bolo. Is it okay? Then we will learn some of the situations which are given in NCERT, which has been asked previously also, important situations. Yeah. Okay, no problem. Yeah. Correct. Tulsi, correct. We will do questions. Don't worry. Yeah. We will do some question where we will see how to convert frequency from RPM to RPS, omega, all those numericals we will do. That will cover in numerical part. Yeah. Okay, no problem. Yeah. Now I am going to talk about 3 situations here back to back. All these situations, why I am talking especially, because these are given in NCERT 2-3 times. All this situation has been already asked in our NEET exam. So dhyan dena, be focused. Be focused, you can write CBI NCERT. I will tell you how to calculate torque with the help of r perpendicular into f. From there, how to calculate alpha, then how to calculate omega, theta, alpha, all these things we will talk. Yeah, you can write CBI NCERT. I will show you with the help of one example how to use all these situations. Yeah. And going to be very important. If you see previous year NEET questions so many times, they will, yeah, today I will send, yeah. Khaji, I will send today homework, no problem, yeah. Chala baga important, CBI, yeah, CBI NCERT. So dhyan do, just here, no problem, yeah. Here one situation is very famous. 2 situations at the same time I will talk. So dhyan do, if you understand first one, second one will become more easy for you. So just here, yeah, okay. First situation which is asked here, for example, assume you have a disk. For example, assume you are having a disk. Yeah, okay, no problem. Yeah. Assume you are having a disk. No problem. This is the disk. Assume you are having a disk, no problem. This is the disk that we have. Yeah, okay. Acha, can you tell me in place of disk what else body they can give you? Disk or solid cylinder, both will have same meaning. Sometimes they talk with the help of disk, sometimes they talk with solid cylinder. No problem, yeah. So assume we have a disk or we have a solid cylinder of mass m and radius r. No problem, yeah. Assume we have a disk or we have a solid cylinder. You know, disk and solid cylinder both will be same. Disk and solid cylinder, moment of inertia same, behavior will be same. So assume we have a disk or we have a solid cylinder. No problem, yeah. They will say center of the solid cylinder is fixed. Fixed means we have fixed the axis. Actually we have hinged the center of solid cylinder, or we have hinged the center of disk. Now they will say over this disk I am wrapping one string. One string I have wrapped, one string I have rolled over this disk or solid cylinder. And I am going to pull this disk. I have wrapped one string over it, and I am going to pull this string with force F. And you know this force F will be same as tension in the string. You tell me, if you pull your string like this, what will happen to the disk? If you pull your string like this, what will happen to the disc? If you pull the string with tension T, what will happen to the disc? Batao bhai, what will happen to the disc? Disc will now rotate. Disc will now rotate about center. Yeah, it's a very simple situation. It will not roll. Don't say roll because center we have fixed. So what will happen if you pull it? Your disc is going to rotate. And if your disc is going to rotate, it must have some angular acceleration. So question is asked here, so if you pull the string by tension T, what will happen if you pull the string by tension T? Disc will rotate, sir. So what will be angular acceleration of the disc? They will ask you angular acceleration. Yeah, very good, yeah. So you can calculate that angular acceleration very easily. Kavya Shri, correct, no problem, yeah. 2, yeah, okay, Remant also very good, yeah. So they will ask you, find angular acceleration. If you pull the string with tension T, what will be angular acceleration of the disc? So I simply say, yeah, okay, no problem. Many people are giving correct answer, very good, yeah. I will simply say, I don't know what will be angular acceleration, but I know, sir, how to calculate torque. And once I know how to calculate torque, I will equate that torque to I alpha, I will get my alpha. So first I will calculate the torque. I know, sir, torque I will calculate with the help of R perpendicular into F. And once I will get this torque, I will equate this torque to I alpha. No problem. First I will calculate torque. I will equate that torque to I alpha. Now torque will be, sir, R perpendicular into F. Sir, what is F? F is the tension in the string. And what is the perpendicular? R perpendicular. If you remember, I said you R perpendicular is the perpendicular distance of force from axis. So axis ekada, force ekada. So R perpendicular will be equal to radius of the disc. Here R perpendicular will be equal to radius of disc. If you remember in the last class, this is what I was saying you. R perpendicular into F. R perpendicular is the perpendicular distance of force from where? From axis. So akada axis, akada force. So this is your R perpendicular. So R perpendicular will be equal to radius. Force will be equal to tension. Now this will be I alpha. Now you know moment of inertia. Yeah. Okay, no problem. Now you know moment of inertia of the disc about geometrical axis. Axis of rotation is geometrical axis. So about geometrical axis, you know moment of inertia of the disc. mr square by 2 into alpha. I for the disc will be mr square by 2 into alpha. Now from here R cancel, you can calculate alpha. You can send remaining this side. So alpha will become, this 2 will come here. So 2t by m into r. This is the alpha of disc. Is it okay? Bol do bhai. Alpha of the disc 2t by mr. No need to blindly remember this. After class, again do this question. You will get better idea. Then you can keep this value in your mind. Tell me, in place of disc, if I take hollow cylinder or ring, in place of this someone says, no sir, I don't have disc, I have ring. Or if I have hollow cylinder, tell me where change will happen. If you have a disc or in place of disc, if you have ring or hollow cylinder, where will be the change? Where will be remaining things same? Where will be the change? Change will be in the value of I. Now I about geometrical axis will be very good, very good. Many people are saying, bahut badhiya, yeah. Kavya says that is not the answer. Answer will come T by MR. If you are using ring or hollow cylinder, then you will simply say, sir, now same concept. Again, force will be tension in the string. Again, you will say, sir, this force will produce torque, sir. How much torque will come, sir? R perpendicular will be radius into F. F will be equal to tension. That will be I alpha. But I for ring will be only mr square. For disc, it was mr square by 2. But for ring, it is only mr square. So I into alpha. Now 1R will get cancelled. Alpha will be coming as T by MR. Is it okay? Is it okay? Bolo, 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 bolo. They ask for hollow cylinder also and they ask for solid cylinder also. Both are given in NCERT exercise question. No problem, not hollow sphere, it was hollow cylinder. Okay, no problem. Yeah, Harita, very good. Yeah. So first you can write this, then I will give you one question where values will be given. Sometimes they play trick with the values also. Come on, do one question. Come on, Torga, time le do. Come on, do one question. You write, a string is, just you have to use these values. Yeah, a string is, okay, no problem. Yeah, a string is wrapped. A string is wrapped on a solid cylinder of mass 10 kg. A string is wrapped on a solid cylinder of mass 10 kg and radius 1 meter. A string is wrapped on a solid cylinder of mass 10 kg and radius 1 meter. If cylinder is free to rotate about geometrical axis, if cylinder is free to rotate about geometrical axis, then find its alpha. If the cylinder is free to rotate about geometrical axis, then find its alpha. If tension in the string is, then find alpha. If tension in the string is 100 Newton, then find alpha. If tension in the string is 100 Newton, tension is given 100 Newton. Hanudeep, बहुत बढ़िया, very good. Kavyashri, very good. Shivani, very good. Lakshmi, very good. Kasturi, very good. Shyam, very good. Yeah. Radian per second square. That is the SI unit of alpha. Whenever you have to use alpha, you have to always use radian per second. Answer will come 20. I will simply say, just now we studied for solid cylinders, alpha will come 2T by MR. Now we'll just put the value. We will put the values at 2T. T vanda. Mass padi. R okati. So from here you can cancel, you'll get answer as 20 radian per second square. This unit is important. Sometimes they play with the unit also. I will give you next question. Come on. You write, yeah. You write. When a hollow cylinder, you write the question. When a hollow cylinder of mass 10 kg and radius 1 meter, when a hollow cylinder of mass 10 kg and radius 1 meter, when a hollow cylinder of mass 10 kg and radius 1 meter is pulled by string, when a hollow cylinder of mass 10 kg and radius 1 meter is pulled by string, then its angular acceleration is found to be, then its angular acceleration is found to be 2 revolution per second square. Then its angular acceleration is found to be 2 revolution per second square. Find tension in the string. Find tension in the string. Mass of the hollow cylinder given, 10 kg, radius of the hollow cylinder given 1 meter. People do mistake here, that's why I have given you. You see, people are giving answer 20 Newton, which is a wrong answer. 20 Newton is the wrong answer. You cannot use alpha unit as revolution per second square. You have to convert into radian per second square. Yeah, Hanudeep is saying correct. 20 is wrong answer. You cannot use revolution per second square for unit of alpha. First convert into radian per second square by multiplying with 2 pi. You know, whenever revolution is there, you have to convert into radian by multiplying. Answer will come 40 pi. People are using correct formula. Sir, we are using alpha will be equal to hollow cylinder, so T by MR. But always be careful with alpha. Unit of alpha, SI unit of alpha is not revolution per second square. You cannot use this value here. You have to convert into radian per second square. 1 revolution means 2 pi radian. So 2 revolutions. So that's why in order to convert into radian, multiply with 2 pi. So that will become 4 pi radian per second square. Now you can use this value of alpha. Now alpha will become 4 pi. This will be equal to T by M. M10 R1. So from here tension in the string will come 40 pi. If required, you can put the value of pi also 3.14. Is it okay, Boldo? Are you getting idea where people did mistake? Everyone realized the mistake? You have to be careful. This is the unit they play. In circular motion, they always, these are parts of circular motion. You have already done. They will always play with the unit. I'm giving you time of 2 seconds. See both situations. We will move further. Third important situation we are going to talk. Easy only, but you have to be careful about units. Whenever revolution is there, you have to convert into radian by multiplying with 2 pi. Now we are going to move towards third important situation. Chamka sir, bahut badhiya. Well again, sir, bahut badhiya. So you have to be careful. People in hurry do mistakes, so don't do such mistake. No problem, no problem. Now be focused, just here. Okay. Third famous situation I am going to talk here. Third famous situation I am going to talk. For example. 3 times already this situation has been asked in our NEET exam. So again, chance is there, question can come in the coming exam. So dhyan dena, be focused, just here. Very simple situation, just see. For example, this is a rod. For example, this is a rod. If you hold one end of the rod like this, you cannot hold like this. If you hold like this, you are not providing any axis. First, for any body to rotate, you have to provide axis to the body. So for example, if I am holding pen like this, other side I am holding with my hand. You tell me if I remove my hand, what will happen to the pen? You tell me if I remove my hand, what will happen to the pen? Bolo bhai, if I am holding pen like this, means I am trying to give one axis to the pen. If I remove my hand, what will happen to the pen? Bolo, if I remove my hand, what will happen to the pen? And jaldi batao, if I remove my hand, what will happen to the pen? Bolo. Targa, if I remove my hand, don't say pen will fall, sir. If you remove your hand, pen will rotate. If you remove your hand, pen will rotate. Not only with the pen, If you have bottle also, for example, this bottle is there. And okay, I'm holding the bottle from here. If I remove my hand, bottle will also rotate. If the bottle will rotate, it must get torque now. For rotation, you require torque now. This bottle must have alpha now. Can you tell me who will give torque to the bottle? Who is giving pen? Who is giving torque to this pen? This pen you are removing, this pen is rotating, sir. So who is giving torque to the pen? Who will give torque to the pen? Jaldi bata, who will give torque to the pen? Kaun de raha? I am not applying any force. Who is giving torque to the pen? Who is giving? Gravity. mg will give torque. Here mg will give torque about axis. Due to that torque, your pen will rotate. So question is asked to calculate alpha. And this situation I think you will be able to do by yourself. You try to do by yourself. Come on. mg will give torque. Okay, no problem. So you can write the question. You can write. Okay. You write. You can do by yourself. You write. In the given figure, a rod is free to rotate about one of its end. In the given figure, a rod is free to rotate about one of its end. Find its alpha when it is released. Kavya Shri, very good. Find its alpha when it is released. Find its alpha when it is released. Remant, very good. Yuva Bharti, very good. Many people are giving answer. So first calculate torque. Alpha you cannot find directly. So first calculate torque with the help of R perpendicular into F. Shivani very good, LTYDG very good, Lakshmi Sajja very good, Kushma Kumari very good. Many people are giving answer. So first calculate torque with the help of R perpendicular into F. Once you'll get torque, equate it to I alpha. And axis is end. So I must be ml square by 3. People do mistake, they equate for rods, sir, we studied ml square by 12. That was about center. Axis is not center. Dekho, aankh khol ke dekho. Axis is end. So ml square by 3. So I will simply say, yeah. Many people got, some people are not getting, so just see here, yeah. I will simply say, sir, what will happen? What will happen? Once you remove your hand, till the time you are putting your hand force, your force is balancing mg. But once you remove your hand, mg of the rod will act vertically down. Sir, mg will act. I think everyone knows gravitational force always acts through center of mass. That's why you can balance a pen at the center. You can balance anybody at the center because we always consider gravity to be acting from center of mass. Yeah. So yeah, 3g by 12 will come. Yeah, very good. बहुत बढ़िया. Tejashwini very good. Manas very good. Yeah. I'll simply say, sir, once you remove your hand, gravity will act vertically down mg. Now this gravitational force will give torque about axis. So we require R perpendicular. Can you tell me how much R perpendicular will come? Sir, here R perpendicular means perpendicular distance of force from axis. R perpendicular will come, sir, L by 2. So first I will calculate torque. So torque will be coming as R perpendicular into F. Now what is R perpendicular, sir? R perpendicular is L by 2. F is, sir, mg. And I know this torque will be also equal to, sir, I alpha. So I'll equate this torque to I alpha. And what is I of the rod? What is I of the rod about end? What is I of the rod about end? ml square by 3. You studied about. Axis is not center. Axis is end. Axis is end. So I of the rod will come ml square by 3 into alpha. Now from here mm you can cancel. LL you can cancel, and from here you will get this side g by 2 will be equal to here L by 3 into alpha. So from here you can find alpha will become 3g by 2L. Is it okay? Sabko samajh mein aaya? Yeah, very good. Everyone got the idea how we calculated alpha? 3g by 12. Yeah, बहुत बढ़िया. अच्छा, sometimes in place of asking alpha they ask what will be acceleration of center of mass. Yeah, okay, this is angular acceleration. Sometimes they ask with how much acceleration center of mass of the rod will fall. So whenever acceleration of any point is asked, you can always use A equal to alpha r. And what is alpha? They will ask you for center of mass. So for center of mass you can write, sir, you want acceleration of center of mass. So ACM will be equal to alpha. What is alpha? 3g by 2L. Alpha into R. What is R for center? Our center will move in a circle na baba. What is R for center? L by 2. So from here LL will get cancelled. You can get acceleration of center of mass also. That acceleration of center of mass will come 3g by 4. Is it okay? 3g by 4. That is the acceleration of center of mass. Yeah. So this is how we can calculate all these things. Now, just see here. Yeah, okay. Acha, I said you know this question came 2-3 times in the NEET exam. So always they don't ask with the same language. Same question they ask, same concept they ask, but next time they ask the same question like this. Dhyan do, be focused. Yeah. Sir, we calculated alpha. Alpha will come to 3g by 12. But always in the NEET they will not give you this diagram only. Sometimes they say, same question they will ask you and they will say, one end of the rod, we are hanging with the help of string. Other end is the axis. And one end of the rod we are hanging with the help of string. Now they will say, if string is cut, If you cut the string, can you tell me if I cut the string, what will happen to the rod? If I cut the string, what will happen to the rod? If you cut the string there, that is scissor. Katram. Yeah, that is katram. So, okay. If you cut the same thing, same concept, only in place of our hand, string is there. If you cut, again rod will rotate about end. Again mg will. So here also will get same alpha 3g by 2l. Same acceleration of center of mass, that is 3g by 4. Same question. Yeah, nothing changed. Everything will be same. Or sometimes they can draw same diagram like this. Yeah. Now they will say both ends of the rod we are hanging with the help of string. You can see both ends of the rod we are hanging with the help of string. Again they will say if one side string is cut, again you know if you cut this, again this rod will rotate about end. Now again you will get same alpha 3g by 2l. Again you will get same ACOM, that is 3g by 4. Same answer will come always. All of these situations are same situations. Is it okay? Is it okay? Yeah, same situation, rod will rotate about the same axis with same alpha. I'm giving you time of 2 seconds. See all this situation, we will move further. See all this situation, we will talk about some more questions from here. These are the famous situations which we have covered. Once you can see, once completed, you can say done, sir. Easy situations, but famous situations, yeah. And once I will say done, sir, you start saying done, sir. OP ka ledu, sir. OP ka ledu. Why to have OP ka? Come on. Sir, NEET 2024 is waiting for us. Why to have OP ka? We have to work hard and we have to become doctor. That's it. Things are already decided. Padhna hai, doctor banna hai, khatam. Tata, bye bye. So you have to study, that's why. Okay. Manas, you can put blade also, no problem. From here only they got idea to put blade in Pushpa. That one was there, who was putting blade in his mouth. From here only they got idea. Once I was teaching them this, they said, why to put scissor? We can put blade also. So I said, yeah, you can put blade in the mouth also. So from there they got the idea. Yeah, Manas. Yeah, okay, no problem. He's saying I was also there that day, sir. Okay, no problem. Okay. Now they do. Okay, no problem. Yeah. So again I will tell you, yeah. He is Bamardi. Oh, Bamardi, its name was Bamardi. Okay, no problem. No. Oh, sir. Okay, no problem. No. Dhyan do, be focused here. So what I told you here, yeah. Okay. So what I told you here, you have to calculate torque with the help of R perpendicular into F. Then you have to equate that torque to I alpha. From there alpha will come. In the case of disc or solid cylinder, we got alpha as 2T by MR. In the case of ring, we got T by MR. In the case of rod, we got 3G by 2L. So these are the values that we got. Now we will do some questions based on equation of motion. If you see previous year NEET question, so many questions they have asked based on equation. Means they will give you alpha or they will give you omega. They will ask you different situation. So we'll do 1-2 questions from there. Come on, you can start. Yeah, you have done already this type of question in circular motion, but again I will revise that part because important question is asked from here. You can write. Come on. You write. A rigid body starts rotating. A rigid body starts rotating from rest. A rigid body starts rotating from rest with a constant alpha of 2 radian per second square. A rigid body starts rotating from rest with a constant alpha of 2 radian per second square. Find. First you can write. Find first angular velocity after 10 seconds. In 10 seconds, how much angular velocity your rigid body will have? Second, angular displacement after 10 seconds. In 10 seconds, how much angular displacement it will have? Third, number of revolution in 10 seconds. In 10 seconds, how many revolution body will perform? Same questions you have done in circular motion also. Time given omega naught starting from rest means initial omega that we represent by omega naught. Omega naught is sunna. All three answer you can give at once. First answer will come 20 radian per second. Units you have to be careful. Yeah. Twarga twarga bhai. Samayam ledu mitrama. Samayam ledu mitrama. Sanganama rannama. Second answer will come 100. Very good, Kavya. Gautami, very good. Manogna, very good. Shyam given only 2 answers. Yeah. Manas has given all the answer. Very good. Manas finally used the blade and you got all the correct answer. Very good, Manas. Yeah. I will simply say I don't have time. Samayam ledu mitrama. Samayam ledu mitrama. Sarnama ranama. Okay, no problem. No problem. I will simply say, sir, omega will be first equation. Omega will be equal to omega naught 0 plus alpha t. Alpha is 2, time is 10. So omega will come, sir, 20 radian per second. No problem. Sir, theta I can use first equation. Omega naught t plus half alpha t square. Omega naught is 0. So directly half alpha. Alpha is 2 into t square. That is 10 square. So from here theta will come 100 radian. And number of revolution we know, sir, theta by 2 pi. That is 100 by 2 pi. 2 pi. That means 50 by pi. If required, we can put pi 3.14 also. Is it okay? Is it okay? Bol do kaman torga. Ha. Yeah. Samayam ledu mitrama. Ranam sarnama ranama. Yesterday only I learned. Samayam ledu mitrama. Sarnama ranama. Yeah, okay, Badaya dialogue. Yeah, okay, no problem, yeah. So this is how we talk about. Do the next question, come on, do the next question. Chalo, Twarga bhai, Samayam ledu mitrama. Twarga. Do the next question, you write? Jai Balya. Okay, no problem, yeah. Okay. Do the next question. Chalo. You write? Yeah. Samarama maranama. Okay, no problem. Yeah. Do the next question. Chalo, theek hai bhai. Jai Balya kar lena baad mein question banao. You write? A rigid body is rotating with frequency of okay, no problem. Yeah. A rigid body is rotating with frequency of 120 RPM. This is also previous year NEET question. A rigid body is rotating with frequency of 120 RPM. Find the torque required. Find the torque required to completely stop it in a time of 10 seconds if its moment of inertia is find the torque required to completely stop it in 10 seconds if moment of inertia is 10 kg meter square. If moment of inertia is 10 kg meter square. Means using equation you have to first calculate alpha. Once alpha will come, torque you can calculate as I alpha. Raymond, that answer is wrong. First thing you have to convert this frequency omega, you have to calculate initial 2 pi f. F is given in revolution per minute. You have to convert into per second. Then you have to use first equation to get alpha. Final omega is 0 because it is stopping. Yuva Bharti, your answer seems to be correct. Very good. Yeah. This is also a famous type of question. Yeah. Vargav, correct. Sir, initial frequency given, that means I can find initial omega. No problem, no problem. I'll give you next question. People are feeling little problem here. Yeah. Answer will come 4 pi. Shyam, correct. I will simply say, sir, you have given me, they are already saying body is rotating with this much of frequency, means initial omega I can find, sir. Omega naught will be equal to, sir, 2 pi f. So from here 2 pi f 120 rpm, but you cannot use rpm because minute is not unit of time. Minute is not SI unit of time. So you have to convert it to second. That is 120 by 60. So from here you will calculate initial omega. From here omega naught will come. This will get cancelled 2. 2 into 2, that is, yeah. Initial omega will come, sir, 4 pi. So once we got initial omega, final omega we know, sir. Final omega will be 0. Time is given, sir, 10 seconds. That means I can use first equation of motion. I will simply say, sir, omega equal to omega naught plus alpha t. Now final omega I know, sir, 0. Omega naught I know, sir, 4 pi. Plus alpha we don't know, sir. Time we know, sir, 10. So from here alpha will become, alpha will come. Minus 4 pi by 10. Minus is showing that it's a retarding force. Of course, yeah. You are going to have retardation. It is angular retardation. If anyone asks you torque, torque I know, sir. Once I got alpha, torque I know, sir. Torque will be I into alpha. I value we know, sir, 10. Alpha value we know, sir, minus 4 pi by 10. Now from here 10 will get cancelled. Torque we will get minus 4 pi Newton meter. Newton meter is the unit of torque. Minus is showing, if minus is there in option you can go with it, or sometimes values are only given. So torque required will become 4 pi. Is it okay? Bolo bhai. Is it okay? Bol do Twarga. Is it okay? एक और क्वेश्चन दूं? One more question required or enough? Okay, Kavyashri. One more question required or enough? अरे भाई बोल दो भाई, क्या हो गया? One more. Srikar is saying it's not enough, Baba. One more question you require. Then your brain will develop. This is a very important. This 2-3 questions has been discussed in NCERT like this. So last question. Chalo, ek aur question banao. Badakam people say no, sir. Enough. Okay. You do one more question. Come on. You write. You write. A rigid body. Angular velocity increases. A rigid body, angular velocity increases. A rigid body, angular velocity increases from 240 rpm to 360 rpm. A rigid body. Okay. I will send in the evening. Yeah. A rigid body angular velocity increases from 240 rpm to 360 rpm in a time of 2 seconds. In a time of 2 seconds. In a time of 2 seconds. If its I is 10 kg meter square, find torque. If its I is 10 kg meter square, find torque. If its I is 10 kg meter square, find torque. If its I is 10 kg meter square, find torque. So initial frequency given, final frequency given. Shyam seems to be correct. Very good, Shyam. Initial omega will come, say, I think 8 pi. Final will come 12 pi. So 4 pi, हाँ. Sam correct. बहुत बढ़िया Sam. Very good. Very correct answer and very fast answer. Vargav, very good. Reshma, now minus will not come, Baba. Final is more, initial is less. Their final is stopping, that's why minus came. I will simply calculate initial omega. Sir, initial frequency given, so initial omega I can find, sir. Omega naught I can find, sir. 2 pi f. F will be, sir, 240 by 60. Now from here, if you calculate initial omega will come 8 pi. Similarly, you can find final omega. Again, final omega will come, sir, 2 pi f. F will be now 360 by 60. That will be coming as 12 pi. Now you can use time given, so you can use first equation. Yeah, I think everyone is getting it. Hanudeep, very good. Tejaswini, very good. Kavyasri, very good. So I will use equation of motion omega equal to omega naught plus alpha t. Now here's the final omega given 12 pi. Initial omega given, sir, 8 pi. Plus alpha we don't know. Time is given 2 seconds. So from here alpha will come, sir, 2 pi. Once you got alpha, torque you can calculate. Torque will be equal to I alpha. That is I is 10, alpha is 2 pi. So that means torque will be coming as 20 pi. Is it okay? Is it okay? Bol the bhai. Is it okay? I think you'll be able to do. Yeah, no problem. Now I am happy. Yeah, that you'll be able to do. Yeah. Achha, in the place of time, if I give you number of revolution, then in place of time, if I give you number of revolution, then here I gave you time at 2 seconds. If I give you number of revolution, after 2 revolution, its angular velocity became 360 rpm. Then kya karoge? In place of time, if I give you number of revolution, then in place of time, if I give you number of revolution, then batao jaldi. In place of time, if I give you number of revolution, after 10 revolution, its angular frequency became 360 rpm. Then what you will do? If they give you number of revolution, then find theta. Because you know n will be equal to theta by 2 pi. So find theta, n into 2 pi. And now you can calculate your alpha using third equation. Because now time is not given now, theta is given, omega initial, omega final, theta, then alpha will be calculated using third equation. अरे बाबा, समझ में आ रहा है? हाँ, third equation then we have to use. Time not given na bhai, so you cannot use first equation. We are using first equation to find alpha because time was given. So when number of revolution given means, if number of revolution given means actually theta is given. If theta is given means, sir, how to relate final omega, initial omega, theta. So third equation is for that purpose only na. Use third equation, you'll get the answer. So this is how we talk about all this situation. Now we'll talk about one more part. You can write, no problem, yeah. Okay, Shyam. Shyam finally gave one Hindi commentary. Spust master. Okay, no problem. Yeah. Angular displacement will be given. You can use it. Yeah. Okay, no problem. Yeah. Now we'll talk about last part. We have almost completed. Yeah. Okay. Okay. We have almost completed our syllabus for the exam also. One last thing. Numerical is not there. Just I will give you one little idea. Yeah. Okay, Manas. Okay. So one last point I will talk. Just here. Yeah. Okay. You can write mechanical equilibrium. You can write mechanical equilibrium. Numericals we will do after holidays. After holidays we will talk about numericals which are asked from here. Right now just we'll study about what is meaning of mechanical equilibrium. So dhyan do, just here. Okay, no problem. Yeah, okay. Now, so always remember, in physics we have two types of motion. This is what you are learning. Yeah, one motion which we studied previously. Very good, Kavyasri. I will send question. Tejaswini, I will send the question. एक बार देख लो इसको. Yeah, ध्यान दो. Always remember in physics we have two types of motion. One is translational motion, other is rotational motion. So that's why in physics we have two types of equilibrium. Possibility is there na, a body is only translating but not rotating. Possibilities there are, for example, if you look at the fan over your head, fan is only rotating, it's not translating. So always remember in physics two motions are there. One is translational, other is rotational. That's why two types of equilibrium will come. First type of equilibrium we call as translational equilibrium. Translational equilibrium. And you have already studied for translational equilibrium, condition is net force on the body must be equal to 0. This is the first type of two motions, translational, rotational. So two types of equilibrium will come in mechanics. One is translational equilibrium. For translational equilibrium, F net will be 0. Second equilibrium is rotational equilibrium. Second equilibrium is your rotational equilibrium. Rotational equilibrium. Yeah. Rotational equilibrium means rotational motion is not there. Condition for translational equilibrium, net force 0. So condition for rotational equilibrium is net torque must be equal to 0. Net torque must be equal to 0. So two motions are there, translational motion, so translational equilibrium, net force 0. Rotational motion, so rotational equilibrium, net torque 0. And when the body has both equilibrium, for example, a body is neither translating. Look at this pen. This pen is neither translating nor rotating. So when body do not translate, do not rotate, we call it as body in complete equilibrium. Body is in complete equilibrium. And that complete equilibrium in physics we name as mechanical equilibrium. We say body is in mechanical equilibrium. Means on that body net force will be also 0, on that body net torque will be also 0. Is it okay? Complete equilibrium means mechanical equilibrium. Translational equilibrium also there, rotational equilibrium also there. And always remember net torque 0, but you know that torque is always calculated about some reference. Torque is always calculated about axis. But if the body is in rotational equilibrium, means it is not rotating. If it is not rotating about every point, about any point, if you calculate, net torque will always come 0. About any point, net torque will be 0 if the body is in rotational equilibrium. Question is asked, if a body is in rotational equilibrium, net torque will be 0 about which point? About center, about any place, about any point, net torque will be 0. Yeah. And those important points which we use will be our, sometimes we will say, depending on our requirement, center of mass. Sometimes we will say our hinge point, or sometimes we call it as support point. These things you will learn when we will do numerical from here. Is it okay? First right now you can write, no problem. Yeah. About any point. Now student get confused. Sir, about any point means, can I write net torque about my nose to be 0? You can write. But that is not in the numerical now. So in numerical, which point we will select, sir, for our best answer? That is either center of mass, hinge or support. Is it okay? बोल दो भाई, बोल दो, त्वरगा, एक बार बोल दो. So we'll do numericals from here after our holidays. Yeah. So enjoy your Dasara holidays. Don't take much stress. If you get time, study. Otherwise, relax. But you know, you chill with study. Yeah. You chill with study. So chill with study. Little bit of a study you can do. Remaining things we will talk after the summer holidays. For today we'll be ending our class here only. Tata, bye bye, take care. Samayam ledu mitrama. Ramana, Sanama, Ranama. Okay, Samayam ledu mitrama, Ranama, Manama. Okay, no problem. Happy Dasara to all of you. Tata, bye.